Hi everyone, the channel Knowledge Academy welcomes you. In this video, we are going to discuss line coding formats. Before entering into the video, kindly subscribe my channel Knowledge Academy. Now let us discuss the topic. So what is meant by line coding technique? Where do we go for line coding techniques? So those things we are going to discuss. So here in digital communication, what happens? The source generates the signal and the signal is in analog form. But this signal need to be converted into digital form. So using sampling, quantization and encoding, it is converted into the signal is converted into zeros and ones. But these zeros and ones are not suitable for transmission. The zeros and ones need to be converted into a waveform, and this conversion is done by line coding techniques. Okay, so here there are many different types of line coding techniques available. We shall discuss one by one. Here the techniques, the different types of line coding formats are unipolar non-return to zero, unipolar return to zero, polar non-return to zero, polar return to zero, bipolar non-return to zero, bipolar return to zero, Manchester format. And apart from that, other techniques are also available like natural coding technique, gray coding techniques. So let us discuss one by one. Let us assume that an analog signal is converted into digital form like this. Okay, into zeros and ones. 0 1 1 0 1 0 0 0 1. So here this is an example. Okay, an analog signal, it may be a speech signal or an image signal or a video graph signal. So that signal which is in analog form is converted into digital form like this, zeros and ones. Okay, now let us assume that we are going for unipolar non-return to zero. So how these zeros and ones are converted into waveform using unipolar non-return to zero coding technique? Let us see what happens in unipolar non-return to zero. Uni means single, so unipolar, single polarity. Okay, whenever the signal is 1, okay, whenever the bit is 1, it is represented by a polarity, okay, an amplitude. Okay, whenever the bit is 0, the value of bit is 0, it is represented by 0 amplitude level. Okay, so that is shown here. Okay, the first bit is 0, it is represented by 0 amplitude level. Okay, and the second bit is 1, it is represented by an amplitude level of a volt, and again 1 represented by an amplitude level of a volt. So here unipolar non-return to zero means, here again I have to mention the importance of non-return to zero. So non-return to zero means for the entire bit duration, the amplitude level in the waveform represent that particular amplitude level. It does not come to zero. Okay, so it will be more clear if I speak about return to zero. Okay, so this is regarding unipolar non-return to zero. The bit value 0 is represented by 0 amplitude level, whereas the bit value 1 is represented by an amplitude level of a volt. Okay, let us speak about unipolar return to zero now. So unipolar return to zero also, it is similar to unipolar non-return to zero, but the only difference is in between the bit duration. Okay, after reaching the half of the bit duration, the amplitude level falls back to 0. Okay, for example, here when the bit is 0, bit value is 0, it is represented with 0 amplitude level. So here it is 0 amplitude level. When the bit value is 1, it is represented with an amplitude level of a volt, but not for the entire bit duration. After reaching half of the bit duration, the amplitude level falls to 0. Okay, so that is return to 0. It is returning back to 0. Okay, that is the meaning. Okay, again when the bit value is 1, it is represented by an amplitude level of a volt for half of the bit duration, and for remaining half of the bit duration, it is at 0. Okay, so this is unipolar return to 0. Now polar non-return to 0. So polar non-return to 0 means, here the bit values 0 is represented by a negative amplitude level, and the bit value 1 is represented by positive amplitude level. Okay, so 0 is represented by negative amplitude level of minus a volt, and 1 is represented by a positive amplitude level of a volt. Okay, so for the entire bit sequence, this is the representation, and this is the line coding format using polar non-return to zero technique. Okay, now let us speak about polar return to zero. So similarly, polar return to zero means, as I mentioned earlier, for half of the bit duration it represents its amplitude level, and for remaining half of the bit duration it returns to zero amplitude level. So just see, when the bit value is 0, it is represented by amplitude level of minus a volt for half of the bit duration, and remaining half of the bit duration it is at 0. For bit value of 1, it is represented by an amplitude level of plus a volt for half of the bit duration, and the second half of the bit duration it is at 0. So for all the bit sequence it is the condition. Okay, so this is regarding polar return to 0. Okay, now the next technique is bipolar non-return to 0. So what happens in bipolar non-return to 0? Bipolar means, bi means 2, so 2 polarity. So the symbol 1, the bit 1 is represented by 2 polarities, okay, alternatively. So positive amplitude level in one condition, and alternate and for the next one, and for the next bit value of 1 it is represented by negative amplitude level, and for next bit value of 1 it is represented by positive amplitude level. So the amplitude level of bit value 1 is alternated. Okay, so for example, the first bit is 0, it is represented by 0 amplitude level. The next bit value is 1, it is represented by a positive amplitude level of plus a volt, and for the next one it is represented by a negative amplitude level of a volt, minus a volt. And for 0 it is again 0, and the amplitude level is 0. For next one, previous one was represented by negative amplitude level, so the current one is represented by positive amplitude level. And when the next one arises, it is represented by negative amplitude level, and for next one it is represented by, the line coding is represented in positive amplitude level. So this is the thing, the amplitude levels for bit value of 1 alternate, okay, alternate between positive amplitude level and negative amplitude level. This is regarding bipolar non-return to 0. And bipolar return to 0, the same, similar to bipolar non-return to 0, but bipolar return to 0, it represents the amplitude level for half of the bit duration. For second half of the bit duration it returns back to 0. Okay, so the amplitude level 1 is represented by positive amplitude here, and for the first half of the bit duration, and in the in the second half of the bit duration it is represented by an amplitude level of 0. Similarly, when the next signal 1 arises, it is represented by negative amplitude level of minus a volt for the half of the bit duration, and for second half of the bit duration it returns back to 0. So that is why we call it as return to 0. And when next one arises, so here it was represented in negative amplitude level, so this one should be represented in positive amplitude level. So for half of the bit duration it is plus a volt, for second half of the bit duration it is 0 volt. Okay, so this is regarding bipolar return to 0. The next technique is Manchester format. In Manchester coding, zeros are represented. Okay, so here for half of the bit duration 0 is represented as minus a volt. For second half of the bit duration it is represented as plus a volt. So this is for 0. Okay, for 1, for half of the bit duration it is represented in, for the first half, in the first half it is represented in plus a volt, and in the second half it is represented as minus a volt. So this is regarding Manchester format. Okay, so that is what we have done here. The first bit is 0, it is represented as minus a volt in the first half of the bit duration, and in the second half of the bit duration it gets an amplitude, it takes an amplitude value of plus a volt. The next bit is 1, it is represented, it takes the amplitude value of plus a volt in the first half of the bit duration, and it takes the amplitude level of minus a volt in the second half of the bit duration. And the third bit is again 1, so similar to the second bit, it also takes the amplitude level of plus a volt in the first half of the bit duration, and in the second half of the bit duration it is minus a volt. Again the next bit is 0, so 0, it takes minus a volt in the first half of the bit duration, and in the second half of the bit duration it is plus a volt. Okay, so here again this Manchester format can be represented in inverted form. Okay, for example, 0 can be represented as plus a volt for half of the bit duration and minus a volt for second half. Similarly, 1 can be represented as minus a volt for half of the bit duration and plus a volt for second half of the bit duration. So this is the thing. So Manchester can be represented in any form. Either it can be represented in direct form or as an inverted form. But this information, in which format the digital model, digital signal, the digital bit sequence is converted into waveform, okay, using line coding format, that information should be given to the receiver. Only then the receiver can apply the suitable decoding to retrieve the original digital zeros and ones from the codings, from the waveform, right? So this is regarding different types of line coding formats. Now here we have represented the bit sequence. The symbols are represented in single bit. Okay, there is only one bit per symbol, but there are certain conditions in which the symbols may take more than one bit. Okay, for example, let us consider that there are two bits in a symbol. Okay, the signal is represented in the form of symbols. The symbols are constituted by bits. Okay, so here in this example so far we have discussed that symbol is represented by single bit. Okay, now let us discuss into a different condition where there are 2 bits per symbol. Okay, so when there are 2 bits per symbol, how many possible amplitude levels are there? That is the main thing of discussion here. When symbol is represented by single bit level, the positive amplitude levels are plus a volt or minus a volt. So these are the two possible amplitude levels when there are only one bit per symbol. Okay, symbol is represented by a single bit. Okay, when there are 2 bits, when a symbol is represented by 2 bits, okay, so the 2 bits may be either 0 0 or 0 1 or 1 0 or 1 1. Okay, so how many possible amplitude levels are there? 4 possible amplitude levels are there. Okay, in previous condition what happened, when a symbol is represented by a single bit, that single bit may be either 0 or 1. Only 2 bits are there. So 0 is represented by one amplitude level and 1 is represented by another amplitude level. So 2 amplitude levels. Okay, now here when symbol is represented by 2 bits, okay, we have 0 0, 4 amplitude levels, 0 0 0 1 1 0 1 1. So there are 4 amplitude levels. Okay, and we call this technique as quaternary coding. Quaternary coding. Okay, sorry, quaternary coding, QUARTERNARY, quaternary coding techniques. Okay, and if there are 3 bits in a symbol, if a symbol is represented by 3 bits, then how many possible amplitude levels are there? So 0 0 0 to 1 1 1. Okay, so how many? Around 8 amplitude levels are, they have to be represented by 8 possible amplitude levels. So we call this technique as 8 array coding technique. 8 array coding. Okay, so how to find this number of levels? In shortcut. Okay, so it is 2 power n. So when we speak about digital, always 2 power n plays an important role. So 2 power n is the formula to find the number of amplitude levels used to represent the symbol. Okay, so here in the first condition we had n as 1 bit, so 2 power 1 equal to 2 amplitude levels. Okay, so 2 amplitude levels means 2 bits will be there, 0 and 1. Okay, the next one, 2 power n, when there are 2 bits, 2 power 2 equal to 4 amplitude levels. So we have 4 symbols, 4 possible symbols. They are 0 0 0 1 1 0 and 1 1. Okay, this is the thing. And 2 power 3 means if a symbol is represented by 3 bits, then we have 8 amplitude levels, and the 8 symbols are 8 possible symbols are 0 0 0 2 1 1 1, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, right. Now here this is an illustration of representing quaternary coding in different line coding techniques. Okay, so here we have discussed 2 line coding techniques, natural coding, another one is gray coding, and here is the tabulation that gives a lot of information about the amplitude levels for different symbols. Okay, so here there are 4 amplitude levels from 0 0 to 1 1. So 0 0 to 1 1, Okay, and 0 0 is represented by an amplitude level of -3. So it is the minimum, that symbol has the minimum value -3 volt. 0 1, the symbol 0 1 is represented by the amplitude level of -1 volt. The symbol 1 0 is represented by an amplitude level of 1 volt. Similarly, the symbol 1 1 is represented by an amplitude level of 3 volt. And here, this is what we call as natural coding, and this is the waveform representation of the natural coding. So here the same symbol. Okay, so what is the signal that we have discussed? So the same signal, the same bit sequence we have taken, 0 1 1 0 1 0 0 1 1. So we have taken the same bit sequence 0 1 1 0 1 0 0 1 1 0 0 0 1 1. Okay, and we have combined two bits in a symbol. Okay, so 0 1 make one symbol, 1 0 make another symbol, next two bits. So for every two bits we assign it as a symbol. Okay, we consider it as a symbol. Okay, so in the first symbol, the value is, the bits present in first symbol is 0 and 1, 0 1. So 0 1 means this is the symbol 0 1. It is having an amplitude level of -1 volt. So the symbol 0 1 is represented as -1 volt in the waveform like this. The next symbol is 1 0. So 1 0 takes an amplitude value of 1 volt and it is represented by 1 volt. Again, next symbol is 1 0. It also takes an amplitude level of 1 0. The next symbol is 0 0. 0 0 is having an amplitude level of -3 volts, so that is represented, that is shown here. The next symbol is 1 1 1 and it has an amplitude level of 3 volt and it is shown here. So this is natural coding. Okay, now the next one is gray coding. Okay, it is another type of quaternary coding technique. Okay, so gray coding, this natural coding should be converted into gray code. Okay, so 0 0 is converted into gray code and the gray code equivalent of natural code 0 0 is 0 0. Okay, then the gray code equivalent of natural code 0 1 is 0 1. The gray code equivalent of natural code 1 0 is 1 1. So how do we get this? Okay, so 1 0, we have to write the most significant bit as it is, and we have to add that bit with the next bit 1 XOR 0. We should not add, we have to perform the actual operation that is performed here is modulo 2 addition, otherwise XOR operation. So 1 XOR 0, the answer is 1. Okay, so we have got the gray code equivalent of 1 0 as 1 1 here. Okay, similarly the gray code equivalent of 1 1. So how to perform this operation? 1 1 is the natural code, we have to convert it into gray code. We have to write the most significant bit down, and that this bit is taken and it is added with the next bit 1 XOR 1. Okay, 1 XOR 1, the result is 0. So 1 0, we have got the gray code equivalent as 1 0 here. Okay, and there is no change in the amplitude level. 1 1 is represented as 1 volt and 1 0 is represented as 3 volt in gray coding format, whereas 1 0 is represented as 1 volt and 1 1 is represented as 3 volt in natural coding. So there is an interchange here, that is the only change. Okay, so this makes the difference between natural coding and gray coding. Okay, the first symbol here we have as 0 1. The 0 0 1 is taking the value of -1 volt, so -1 volt. Okay, then the next symbol is 1 0. 1 0 is taking an amplitude level of 3 volt, so 3 volt. Okay, so 3 volt. Again, the next symbol is 1 0. 1 0 is taking 3 volt, as I mentioned earlier. Then the next symbol is 0 0. 0 0. 0 0 is taking an amplitude level of -3. It is represented here. And the last symbol is 1 1. In our example, 1 1 is taking an amplitude level of 1 volt, that is shown here. Okay, so this is regarding line coding techniques, different types of line coding techniques. The reason for, again I repeat, the reason for going for line coding format is to convert the digital pulses, digital values, zeros and ones into waveform. Only if it is in the waveform we can modulate it and we can transmit that signal over the channel. This is the reason why we go for line coding techniques. I hope you understand the reason for going for line coding formats and the different types of line coding formats. If you like my video, kindly subscribe my channel, comment, like and share. Meet you again in the next video. Thank you. Bye.